All right. What do we notice about the measurements of these triangles? What do you notice? You might notice a lot of things about these triangles.
They're
They
proportionate.
are proportional. What does that mean?
You could like multiply.
What do you mean multiply?
Double.
Quiet down. You should all be looking up here. What do you mean by proportional?
One is twice as
Like
They have the same.
They're the same
factors, like
common
they have
denominator.
something each other or
Yeah.
something.
Okay. I see that someone said like double. So if I wanted to go from 4 to 8, what do I do?
Multiply by 2.
Yeah, and then from 5 to 10,
Multiply by 2.
and then from 3 to 6.
Multiply by 2.
Multiply by 2. Yeah, what else do we notice about the triangles? It's not every day in algebra we get to use geometric shapes. So let's dive into what
Right.
they are right triangles, absolutely, right triangles.
They're not equilateral.
They're not equilateral. What would that mean?
Is it
That their sides would be equal. So what is that? What are
is
those
that an
triangles?
isosceles triangle? Or is that a
Right
scalene
triangle. It's a-
triangle?
Scalene triangle, where all 3 sides are different. Okay. So these are similar triangles, and you nailed it right away. You said these are proportional. You saw the relationship between the two of them. So similar triangles are scale drawings of one another. They're the same shape, but they're a different size. It's almost like if you had a picture on your phone and you wanted to blow it up on a poster, the picture's still going to look the same, it's just going to be a lot bigger. It's not like all of a sudden your face is going to be distorted unless you did something to the photo to get it that way, which, you know, sometimes happens. So we're going to write this down. This is a key piece of information. I'd like for you to sketch these 2 triangles. I'm not as concerned with you having angle A, B, and C, but the side lengths are going to be very helpful. And what we want to write down, the corresponding sides of similar triangles are proportional, and the corresponding angles have equal measures. So really quick, these 2 triangles, the corresponding sides are proportional, which you already pointed out because you identified that to go from 4 to 8, you multiply by 2. To go from 5 to 10, we multiply by 2. And to go from 3 to 6, again, we multiply by 2. This idea of similar triangles is going to help us work with the slope. So these 2 triangles with their side lengths. The corresponding sides of similar triangles are proportional, and the corresponding angles have equal measures. Does anyone need more time to write this sentence?
I'm ready now.
Okay. Oh,
I'm ready to
the
try.
corresponding sides of similar triangles are proportional, and the corresponding angles have equal measures. So these 2 triangles, their sides are proportional, and this makes sense. 4 to 8 is the same as 5 to 10, which is also the same as 3 to 6. The relationship is 1 to 2. We're doubling to go from that smaller triangle to the larger triangle. We're going to use the idea of similar triangles to help us out with slope today. On the next slide, we're going to kind of dive into it a little bit more. Are we good? Can I slide over? 5, 4,
Hold on.
If you don't see it, it's gonna be on YouTube after school. What?
Oh, it's recording?
So on this slide, we have a graph. What I'd like for you to do with the people around you for about a minute, we're gonna find the slope. Now, let's go over the definition of slope for those of us that need a refresher. The slope is a measure of the steepness of a line or a section of a line connecting 2 points. What have we used to find slope? We've constantly referred to rise over run. And what does rise represent?
Why?
The change in our y value, which is like our value up or down. And then what's our run? The x value, how much we're moving from side to side from one point to another. So what you are going to find right now, you're going to find the slope of the line that's connecting triangle 1, and also the slope of the line that's connecting triangle 2. So find the slope here, and I'll dot these lines. And the slope there. Take about a minute, talk with the people around you, and find those two slopes.
Wait, did you
No.
What's that one here? S2. I think you.
Think about if you need it or not. Look back to your notes if you have it written down. There's other ways you can find it as well. Did anyone come up with a slope for triangle 1 that they would like to share? Sarai, what do you think?
5 over negative 1.
Why 5 over negative 4?
Because the right is 5, and then the run is.
Now the slope is the steepness of a line, so it's how we're moving. And how are we going to find the movement?
Oh.
Yeah.
2 and 5.
What was the rise?
2.
Why 2?
Because we go from negative to negative 1.
Okay, so from here, are you going from this coordinate to this coordinate? So where are we?
You go from 3 to 5 on the y.
Well, our y-axis is our vertical axis. So am I going from 3 to 5 or am I going from 5 to 3? You can go either way. We'll look at both and see how they both work. So if you're starting here and you're going to 3, what kind of 2 is that? You're going down 2. So how would I represent that as a number?
-2.
A negative. And if you're having a hard time with the units, the y coordinate here is 5, and you're going to a y coordinate of 3. So I'm going from 5 to 3, which is 2. I'm going down. I did that. What's our run? 4. Can I simplify that slope?
Yeah.
What would my slope be? Negative 1/2. Good. Does that make what does it mean to have a negative slope?
That you're going on another quadrant. Oh.
You're going down.
Then my line is going down, and that makes sense here. Now, typically, we would advance from this coordinate here to the next one, but maybe if you look at that, you're going the other direction. Maybe you want to start from this coordinate and figure out how you're going to that coordinate. You can still do that. To go from here back here to negative 4, 5, I am going up 2, but what's my run?
4, negative 4.
It's a negative 4 because I'm going to the left, which still simplifies to negative 1/2. It still represents a negative slope. How about triangle 2? What is the slope, my rise, my run of triangle 2?
Let's see.
From here to here. How am I moving from one coordinate to the next?
Are we going up or are we going down? Oh, ew.
Remember, whichever coordinate you go from and to, it's still going to end up being the same slope.
Negative 1 over 2. That's
So from here, down
negative
1, and over
to the right.
2.
Yeah, so
What do we notice about the two slopes?
they're the same.
They're the same. Let's look at this one other way. Let's say I had one big triangle. What is the slope of this large, what is the slope of the line that's connecting this large triangle? From here to here. What's the slope of that line?
1,
4, you rise, 5.
oh, it's the same.
How am I moving? For those of you having a hard time with the slope, think about how are you moving from one point to the next? Because if you can say it, that is your slope. From this coordinate up here, down here, how am I getting there? What am I doing?
Going down
I'm going down
4.
4. And I know that because I'm going from a y value of 5 down to a y value of 1, just to get here. Right, just to get there. But I'm not finishing there. Now what? I went down 4 and over
8.
and over 8. From a negative 4 to a positive 4. I moved 8 units. Does that simplify?
Yes.
Yeah.
To negative 1/2. What do you notice about all of those triangles, the lines, the slope of those lines?
They're both the same.
That they're all the similar triangles, which they are. These triangles are the same shape, just a different size. They're proportional. These 3 triangles, those lines, the slopes were what?
The same.
The same.
Oh, wait,
Do you have a question?
yeah.
Yes.
So, like, that's because they're proportional. What if they weren't proportional, though?
If they weren't proportional,
Yeah.
meaning like a different, if these triangles weren't proportional, then they probably wouldn't line up to the same line.
Oh, so you couldn't do that? So it has to be proportional to have it like this?
The reason we're doing this now is to see that whatever point on a line you go from and whatever point you go to, that idea of rise over run tends to look triangular, right? To go down and over, that kind of makes a triangle. Anywhere on that line, your slope is always going to be the same. If we're talking about something linear, that is a straight line, you can always find the slope because it's going to be the difference between those two coordinates, any two coordinates. And you can always utilize a similar triangle or that rise over run to find the slope. But notice that no matter if it's this tiny triangle or this medium-sized triangle or this big rise over run, it's still going to give you a slope of negative 1/2. We're going to do an activity, and I'm going to pause it so that we can so that I can explain what we're going to do from here.